Start with the 45th example. And what is said here? Two particles each having mass m are placed at a separation d in a uniform magnetic field as shown in figure. They have opposite charges of equal magnitude q. At t is equal to 0, the particles are projected toward each other with speed v. Suppose the Coulomb force between the charges is switched off. First, we need to find maximum value of the projection so that the particles do not collide. So what should be the maximum value of v of the particles so that they don't collide? So first of all, let's see here how the particles will move in this particular magnetic field. Let us talk about first positive particle. So the force on the particle can be easily found by cross product of direction of velocity and magnetic field. So I am taking this as x-axis, this as y-axis, and this as the z-axis. So as this particular particle is going towards right, so I cap cross magnetic field is perpendicular to inward to the board, so that's why it will be minus k cap. Now minus can be taken as outside, so it will be I cross k, and by cross product rule we know that I cross k is minus j and minus minus plus, it will be plus j. So force acting on this particular particle is in the upward direction due to magnetic field, and this particle will move in a circle like this. Similarly, for the second particle, if you apply the same rule, as this particle is negatively charged, so the force acting on this particle will also come in upward direction, the direction, by the same method as you can solve it roughly here. Okay, so the cross product, the direction of the force on second particle will be direction of velocity, which is minus I cap, direction of magnetic field, which is minus k cap. So minus minus become plus, it will be I cross k. I cross k is minus j, but the particle is negative, so that's why it will experience a force in the opposite direction, because if this was positive particle, the force will be downward. So as the particle is negative, so force will be upward, plus j cap. So this particle will also move in a circle of this radius. Now depending upon their motion, these further questions were asked. First, A part of the question. So in the A part of the question is asked, find the maximum value of Vm of the projection speed so that the particles do not collide. Okay, so in the A part, what should be the maximum speed for no collision? So as you can see, this is the particle having speed v at a separation d. Here there is another particle, charge opposite, speed v. So the center of the particle, obviously the center of the particle will be along the line perpendicular to velocity, because radius is always perpendicular to the tangential velocity, and or the force is acting here, centripetal force is always toward the center also we can say. So their centers are also separated by distance d starting from this. As their separation is d, so if this particle moves in a circular path, this also moves in a circular path, so there is a chance they will collide here. Okay, this is radius of particle 1, this is radius of particle 2. So for no collision, what should be the condition? For no collision, the separation d must be greater than or equal to the addition of their radii r1 plus r2. As we know, though both the particles, they are having same mass, same speed, same charge, and they are in the same field, so obviously the radii will also be same, and the radius of each particle will be mv upon qb, that we already know. So the condition is that qbd upon 2m. So v has to be less than qbd by 2m for no collision. Therefore at max, the value of v should vary from 0 to this value. So this is the maximum final value for which the particles will not collide, or they don't collide. So that is the answer to the A part of this question. Now let's see the second part. The second case, what would be minimum and maximum separation between the particles if v is vm by 2? Okay, so if the speed of projection given to the particle v is half of the maximum value that we have been calculated. So obviously they will not collide that separation. So from the motion we can say the centers of the particle are at the separation d. And now particle is moving in a circle of certain radius. Particle 2 is also moving in a circle of certain radius that already known to us like this. So during their circular motion about their centers like this, this is the separation which is minimum, and the minimum separation can be found by subtracting this r and this r from d. So d minus 2r, d minus 2. What is r? mv upon qb, and they said v is vm by 2, and what is the value of vm? qbd upon 2m by 2. So it is qbd by 4m. So I'll substitute the value of v, d minus 2m qb into qbd by 4m. So q cancel, b get cancel, m get cancel, 2 1s are 2 2s are 4. So d minus d by 2. So that comes out to be d by 2, minimum separation. During the same motion, I am showing you the red color, during the same motion as the particle are moving. So when this particle is at this extreme position and this particle at this extreme position, this would be the separation which is the maximum separation, and the maximum separation will be separation between their centers is d, and these separations are the radii. So therefore we can say that the maximum separation between them is d plus 2r, d plus. Already the value of 2r we have finally calculated, which is d by 2. So it will be 3d by 2 r max. That is the maximum separation between the particles, and this is the minimum separation between the particles which is asked in part B. Now let's see what is the part C of the question. At what instant will a collision occur between the particles if v is twice of vm? Now the condition for collision is not satisfied, for no collision is not satisfied, because vmax is qbd by 2m, and they said the speed given is twice of vmax. So if the speed of projection is twice of vmax, particles will collide. Definitely the particles will collide, that we know very well. Now the distance between their separations. So as we know very well, the distance between their centers is d, while what would be the radius at twice of 2vm? So it will be m v upon qb. So it will be 2m qb as it is, and value of vm is qbd by 2m as we have calculated in part A. And the value of qm we have already calculated in part A. So this q cancel, b cancel, mm cancel, 2 cancel. So the radii comes out to be d. It means the particle is having radii equal to d. So this is the velocity, initial velocity of projection, and d. So I will draw this diagram one more time, because d separation d and radius d are same now. So this is the center of particle 1, and at a separation d, that is the center of other particle, while d distance below, because radius is d, so that is the velocity of particle. Here also d distance below, that is the velocity of particle. So now they will meet somewhere here during its motion. When particle come here during this motion, this particle also come at this location. They simultaneously meet at this location. So the radii is d, the radii of this particle is also d, and this is the circular motions of the particle. Okay, so I hope you understood the motion. Now as we can say, this d, so obviously this triangle is equilateral triangle, and this angle is 60 degree. So if this is 60, it means angle turned for collision is 30 degree. Okay, again I will show you here. If this is c1 and the radius of particle is equal to d, a particle is starting from here and it is moving in a circle, and say somewhere here at radius d it is being colliding with the other particle. Here this is at the same separation d, other particle is here, this is the other particle, and this particle is also moving in this direction, so its radius is also d, separation is d, this is d, this is d, so this is 60, so this will be 30 degree. Okay, so angle turned is 30 degree. Angle turned at collision point is 30 pi by 6 radian. So as we know very well, for 2 pi radian or for one revolution, the time required is 2 pi m upon qb, that is time period. So for pi by 6 radian, what is the time interval for collision to turn pi by 6, 30 degree? So time interval for collision will be 2 pi m upon qb into pi by 6 divided by 2 pi. So this pi get cancelled, this 2 get cancelled. So time interval for collision will be pi m upon 6 qb. So pi m upon 6 qb, that is the time instant at which the particles will collide, because they will turn by 30 degree. So this is very clear, this radius is d, when they will collide this is also d and this is also d, that forms an equilateral triangle, this is 60. So obviously when they collide the angle turned by each particle is 30, and for turning 30 degree the time interval can be found by using unitary method by cross multiplying like this. Okay, now let's see now the d part of the question. Suppose v is 2 vm and collision between the particles is completely inelastic, describe the motion. Okay, so same we need to derive now here. So let's take one more slide, d. Now as we have already solved in the d part, that's the velocity at initial moment, and that's the velocity during at collision point or just before collision, and we know that just before collision the angle the angle turned is 30 degree. So for collision I will resolve this v into two part. Okay, so as you can see, if this angle is 30, if this angle is 30, then by alternate interior angle this is 30 and this is 90, so this comes out to be 60. So this component is v cos 60 and this component is v sin 60. Definitely just before collision the other particle will also having the same velocity components, but v sin 60 in opposite direction, that you can imagine, v sin 60 in opposite direction and v cos 60 in the upward direction. So the net momentum in x direction, so as you can see from the diagram, net momentum in x direction will be mv cos 60 minus for the other particle mv cos 60 0. So obviously the initial and final momentum along x direction will be 0. There will not be motion in s direction. While the net momentum in y direction, so the momentum in y direction final must be equal to momentum in the y direction, momentum in y direction initial. So initially as you can see, m into twice of vm cos 60 plus the other particle is also having the same direction upward, m twice of vm into cos 60. As the collision is inelastic, the particles will stick together, total mass will be 2m and final velocity v. So 2m into final velocity equal to cos 60 is 1 by 2, 2 get cancel, cos 60 is 1 by 2, 2 get cancel, mvm plus mvm will be equal to 2mvm, 2m will get cancel. So final velocity will be for the particle, the final velocity of the particle in y direction will be vm. So in x direction the final velocity of the particle in x direction is 0 and final velocity of particle in y direction is vm, so it will move in a straight line along the angle bisector, and that is the motion of the particle. Thank you.